What a limiting reactant is the reactant with the least number of moles present at the beginning of the reaction, which is completely consumed, thus ending the reaction. By finding the limiting reactant, we actually can find how much product we're actually going to produce. Well, to understand limiting reactants a little bit better, let's look at the following example. These gold bars each weigh about 70 pounds and are worth $1.5 million each. But gold doesn't come out of the ground in gold bars. It actually comes in a lot of rock. In order to get the gold out of the rock is pulverized and put in a solution of sodium cyanide. What the sodium cyanide does is reacts with the gold, forming a sodium gold cyanide molecule, which is soluble in water. The rock is then filtered away, and the solution is then further analyzed or further purified to remove the cyanide, and you're left with just pure gold. Now, you don't want to use too much sodium cyanide because it's highly toxic to both a man and the environment. But we don't want to use too little sodium cyanide, and we're going to leave gold in the rock, and we're not going to get as much money for these reactions. So let's try to find the limiting reactant of the following problem. Will 4 grams of sodium cyanide be enough to isolate 10 grams of gold? All right, our first step in this problem, we convert the masses to moles to directly compare them in the equation. So 10 grams of gold divided by its atomic mass, we're left with 0.0508 moles of gold. And we calculate the number of moles of sodium cyanide out of 4 grams, we're left with 0.082 moles of sodium cyanide. Now, we can't stop here because we first have to look at the mole ratios between the two, between gold and sodium cyanide in the product. Now, for every mole of gold consumed in this reaction, 1 mole of sodium gold cyanide is actually produced. However, looking at the chemical equation, there's actually a 2-to-1 ratio of sodium cyanide to the sodium gold cyanide product. So we actually have to divide that initial value of 0.082 by 2 to get how much gold we can get out of this. By dividing by 2, we're left with, we only get 0.041 moles of gold cyanide product. We actually leave a significant amount of gold behind, or 1.9 grams of gold. And in today's market, that's about $200 worth of gold we left in the rock. So this really demonstrates how important a limiting reactant can be. Now let's do a little bit a less expensive reaction that you can actually do at home. If you take 1 gram of magnesium sulfate, Epsom salt, and combine that with a solution of 1 gram of sodium carbonate or baking soda, they actually react to form a white solid that's insoluble in water. Now this white solid is actually magnesium carbonate. Now, how much magnesium carbonate did I just produce? Here's the chemical equation. When we come back, we'll walk through, do this on your own, and when we come back, we'll walk through this problem together. All right, first we need to figure out how many moles of each compound we have. So we calculate, if we divide by the atomic weights, we're left with 0.0083 moles of magnesium sulfate and 0.0094 moles of sodium carbonate. Now, looking at the chemical equation, both of them are in a 1-to-1 chemical equation. So for each atom that we put in for each of these compounds, we're going to produce 1. So we're just looking for the lowest number of moles here, which is the magnesium sulfate at 0.0083 moles. So that's how many moles of the product we're going to produce. We then take that, divide it by, or times it by its atomic weight, and we're left with 0.70 grams of magnesium carbonate.